probably one of the most important sections of the semester. Okay? Being able to solve logarithmic and exponential equations is not only important in this chapter, but it also pops up again often, either in this class or in calculus. Okay? Being able to have one of these types of equations and solve for x happens a lot. Okay? So let's just talk about some different strategies. What if we had an exponential equation? What are some ways that we can solve for x? And there are lots of different exponential equations, but let me give you an example. Okay? What are some ways we would be able to solve for this exponential equation?
Could be rewrite.
Okay, one of the biggest things that's going to pop up into our minds is going to be to rewrite it. If we have an exponential equation, can we rewrite it as a logarithm? Okay. What other strategy do we have for solving exponential equations? Okay, if we can write them as the same base, we do have the one-to-one property. And that will save us some logarithmic help. Okay. What about if we have a logarithmic equation? What are some strategies we can use to solve a logarithmic equation?
Rewrite.
I bet we could try to rewrite it as an exponential. Okay? It goes both ways, right? If x is inside of the logarithm, we can rewrite it as an exponential and it comes out. If x is inside the exponential, we can rewrite it as a logarithm and it pops out. Okay? What other strategies do we have to work with logarithms? Yeah.
Product property.
Yes. We have those properties where we would be able to either condense or expand. Okay. If I have two logarithms that are being added, we know that we can smush them together, right, with multiplication inside. That can be very helpful if we have multiple logarithms in our equation. And then just like exponential, we also have the one-to-one property, to where if we have two logarithms that are equal with the same bases, we know what's inside is equal. Okay? So here is, really this is a section, the more examples we do, the better. Okay? Every problem is going to be a little bit different, so the more types of problems we're exposed to, the better. So I'm going to go through 3 exponential equations. I'm going to go through 2 logarithmic equations, and then I'm going to give you like maybe some partner or group work to do to take us to the end of class. Okay? So, go ahead and write this one down. Having your calculator will also be helpful. So when you do have it written down, if your calculator isn't already out, go ahead and get it out now. Okay, so one of the strategies we wrote down was rewrite into a logarithm. And we do that right now. Why?
Because there's a 2 out front.
Okay, there is a 2 out front. Which means, what do we need to do with that 2? We need to divide it over, okay? This is 2 to the first power. It cannot be combined with 5 to a something else power. Okay, so we do need to divide it over. So 5 to the 2x plus 3 equals 16. That 2 has to be divided over. There's no other choice. Now that the exponential piece is isolated, okay, whatever's raised to a power is by itself. That's what I mean by that. Now that that is by itself, we can change forms. So we can say log base 5 of 16 equals 2x plus 3. Now, this can be typed into your calculator. Don't do it yet. Once we type this into our calculator, we're going to get a value. To solve for x, how are we going to get x by itself? Subtract 3 and then divide by 2. So how about you go ahead and calculate log base 5 of 16. And with that value, subtract 3 equals, divide by 2 equals. You should get a negative answer. Madeline, what are you getting in your calculator? Okay, let's go ahead and round to 3 decimal places. I think that's what I'll ask you to do on your test. So we'll do 3 decimal places right now. Are you getting negative 0.639? Did you have a question? Okay, so here's your log. So our change of base formula is log of what's inside divided by log of the base. So there's your logarithm. And then you can subtract 3 divided by 2. Reckon, are you getting it?
The 2x plus the subtract.
Alright, anyone else having trouble getting there? Okay. Cool. Let's look at this one. This is one of my favorites. Okay. So all of this is divided by 2. So if you do all of them, so you can put your log 16 divided by log 5 parentheses, all of it divided by 2. Oh, yeah. So we have This is interesting, isn't it? What does this kind of look like? Oh, it kind of looks like a quadratic, doesn't it? Okay, so let me ask you this. If I were to write x squared minus 4x minus 5, what would you factor that to? Like that? Okay, well, instead of x squared minus 4x minus 5, we have e to the x squared minus 4e to the x minus 5. Do you agree that e to the x times e to the x is e to the 2x? Okay, so e to the x squared looks like that, e to the 2x. So instead of a normal quadratic, it's like a quadratic in disguise, right? It's a quadratic morphed with an exponential equation. So in order to solve this, we can factor it just like we did over here, except we have e to the x minus 5 times e to the x plus 1 equals 0. So now we have two miniature equations to solve because we need to set both factors equal to 0. So let's start with the one on the left. E to the x minus 5 equals 0. We can go ahead and add that 5 over so that our exponential piece is all by itself. And once our exponential piece is all by itself, we can rewrite. So we have log base e of 5 equals x. And of course, log base e is natural log. I'm going to write it. Somebody punch that into your calculator. What does that approximate to?
1.609.
Good. Then over here, we get e to the x equals negative 1. Some of you can recognize right now what's going to happen. Some of you don't, and it's okay. Because when we change forms, we get the natural log of negative 1 equals x. Some of you right now can tell what's going to happen. Some of you are going to punch this into your calculator. What happens? It says error. What kind of error, Brecken? Did it say like domain error? Non-real answer. Okay, I couldn't remember what. So can we have a negative inside of our logarithm? Nope. So algebraically, it gives us an answer, but it doesn't make sense with the logarithm. So it's not going to be of any use to us. Okay. So I want to see your work, and once you get to a point where, ooh, this isn't going to give me an answer, just X it out so I can see that you tried. Okay. So we only have the one answer, and we crossed out the other one. It's not going to work. All right, this next one is an important one because I think it's one that you have never seen before. The last example we just did, I think some of you may have seen that in an Algebra 2 class, but this one I am almost confident that you have not seen it. Okay. It looks fairly similar to what we talked about here on the board. However, can 3 and 4 be written in a similar base? Okay, they cannot. If it was 4 and 2, we could rewrite it like we did this warm-up problem and use the one-to-one property. If it was 3 and 9, we could write those as the same base, but we can't. 3 and 4 have nothing in common for us to be able to write them as the same power, or base, the same base, okay? So instead we have to use our knowledge of logarithms, okay? So if you get to a situation where you have an exponential equals an exponential, but we can't use the one-to-one property, then we can take the logarithm of both sides. Okay, I'm choosing natural log because it's easier to write. There's no other reason. Okay, you could technically do any logarithm, but it's the easiest to write, and we have it in our calculator. Okay, what would be the benefit to doing this? Well, we have some properties of logarithms, right? Right now, I have no idea how to solve for x. X is in both of our exponents. Well, now that we have a logarithm, can we take those exponents and put them somewhere else? Yeah, we have those expanding and condensing properties. We have the power property. X is a power. We can take it and multiply it out in front. Okay? X minus 1 is a power. We can take it and multiply it out in front. So now we no longer have exponents. Okay? But we still have to be able to solve for x. Okay? So let's take this right here and distribute it to that x minus 1. Okay? So what we have is x natural log of 3 equals x natural log of 4 minus 1 times natural log of 4. Okay. We need to solve for x. How many x's do you see up there?
2.
We see 2 different x's, all right? Well, we need to solve for 1 x. So maybe it would be helpful if anything with an x was grouped together on the same side of our equation. Okay, you might remember solving for y in chapter 1, kind of similar to this. So since we have 2 different items here with an x, let's go ahead and subtract that x natural log of 4. Okay, and now that x natural log of 3 minus x natural log of 4, those are both on the same side. What can we do on that left side?
They have the same base.
They both have x. And since they both have x, we can factor it out. Okay? Remember, we're solving for x, so we don't want to get too wild and crazy. Okay? So now to solve for x, we can divide. So in your calculators, you're going to want to punch this in. But remember, since you have more than one term in the denominator, you are going to want to use parentheses so that the order of operations in your calculator are what you want them to be. What do we get?
I got a negative 2.897.
Got -2.61.
That's what we should be getting. Okay, remember that denominator has to go in parentheses. Oh, you need to make sure you get your parentheses closed off when you open a logarithm. Anyone else having trouble with that? Okay, this is a problem that is new to you. We haven't had a lot of that in chapter 3. Okay? You'll get to practice a problem like this again before you leave, and then you'll have one in your homework. Okay? Don't skip it. Don't skip it. Does anybody have any questions on our strategy before we move on? If we cannot write them as similar bases and we have something to the exponent on both sides, we can take the logarithm of both sides. Okay, that was our strategy. Let's look at a couple logarithmic equations. We'll look at 2 logarithmic equations, and then I'll give you some problems to work on. Let's see. Let's see. Okay, is the logarithm by itself? Yes, yes it is. When the logarithm is by itself, you can rewrite it into an exponential equation, just like when the exponential piece is by itself, we could rewrite it as a log. Okay? If there's anything added, multiplied, divided, subtracted, we cannot rewrite it until those are gone. But right now, our logarithm is by itself. So what we can do is we can take base e to the 5th equals square root of x minus 8. Okay? And now it's just a normal equation. How do we get x by itself? Now what do we need to do? Square both sides, right? So the square and the square root cancel. We have x minus 8 equals e to the 10th power. So now in your calculator, you can take e to the 10th power and then do what? Add 8. Remember, e is approximately 2.7, and if we're taking it to the 10th power, you're probably going to get a ridiculously big number, right? It can be in the thousands, right? Gracie, what'd you get?
I got 42,034.466.
We get that logarithm by itself, and then we can switch forms. Okay? Questions on any of those steps before we do our last one?
So when I put e to the 10th, I got 22026.
But then we have to add the 8 over to solve for x. Will that help your number?
Yeah.
Okay. All right, so let's work on our last one. I've been saying this whole time, we can't rewrite until the logarithm is by itself. Well, I see 2 logarithms. How can I change that? We can condense. We have subtraction. So this is log base 2 of x over x plus 1 equals 2. Now we have 1 logarithm all by itself. Okay, don't forget about our expanding and condensing properties to where that can make our life a lot easier, especially in this case right here. So now we have our logarithm by itself to where we can rewrite 2 squared equals x over x plus 1. Now, please don't panic when there is a fraction. Fractions are not a big deal. And in this case, it's really easy to kind of get rid of the fraction, right? How can we rearrange this to where we don't have a fraction anymore? Okay, we can multiply that x plus 1 over to the other side. So this x plus 1 can get multiplied over here too. Can we all agree that this is 4, right? So we have 4x plus 4 equals x. X plus 1 gets multiplied over to 4. We have 4x plus 4 equals x. So we have 3x equals negative 4 and x equals negative 4 thirds. And that's our answer. And we're all good with that? Jack, what'd you say? If we were to take our answer and plug it back in to our logarithms, is that okay? We'd be okay here, wouldn't we? No, we wouldn't be okay either place. We cannot have a negative number inside of our logarithms. So if we get an answer to where we go back to the original logarithm, if it does not make sense, it cannot be an answer. We call that an extraneous solution. Algebraically it works, but it doesn't work in the context of our problem. Okay? Now, if this were like x plus 2 and x plus 3, we'd be okay with negative 4/3 because negative 4/3 plugged into x plus 2 and x plus 3 would be okay. Okay, but when we plug it into the original, it makes both of those logarithms negative inside. I need to see your work leading up that you got an answer, but X'd it out because it's not going to work.
Technically, like if we were going to go through that whole thing, wouldn't like a negative divided by a negative be a positive?
You're right, but up here, up in the beginning, it doesn't work with the two individual logarithms. Does that make sense?
Yeah.
Okay. So if we started off here, you're right, we'd be okay. But we started off here, so we're not. Taylor, you want to bring your notebook and come join table 6? Since you get your question. Okay. All right, so this is what I'm going to do. For the remainder of the period, I want you to work on some problems, but I think it's going to be a lot more helpful if you work on problems together as opposed to me just doing them for you. Okay? Problems are easy when Mrs. Holman does them for you, right? But you got to take a little bit on yourself. So some of these require a calculator. Some of them you can do without. I'm not going to take it away. But if you can do without a calculator, go for it. I'm going to give you and a partner, pod 1, I'm just going to have you 3 work together. But I want you and a partner to go through these. So these are dominoes. So on the right side is on the left side is an answer, and on the right side is a problem. So just pick a domino, do the problem on the right side, and find the domino that has the answer and put it right next to it. And then that domino will have a new problem for you. Find the answer, put it next to it. Does that make sense? There are 10 dominoes. Your 10th domino should match your first domino. Okay? So you should have 10 problems by the time we're done. Okay? We have 15 minutes. You may or may not get through all 10. I don't know. We'll just see. And it's okay if you don't, but I'd at least like you to try. Okay? But I want you each to have 10 problems on your paper. So you don't split them up. You both pick one and work on it together. And then you get the next one and you work on it together. Okay. Are you going to start the same one? We can start. I have no problem.
Okay. 2x plus 3x. And it's, you want to put on your desk?
Yeah, for now.
Let's go. Okay, let's start with this one.